Alright guys, welcome back to a new video. So in today's video, we're going to be talking about the logarithm. So I'm just going to talk to you about what it actually is and how it actually relates to computer science. So we just have this main equation in the logarithm, and it's just log of a specific base times n is equal to y if a specific base to the power of y is equal to n. Right? In computer science, this base is just 2. So what this is kind of saying is it's just saying that the log, and just think of the power of 2, so let's just say 4, is equal to 2 to the power of some number, right? And this is our log. So in this case, this is 2, okay? So what this is saying is log of 4 is equal to 2, right? So you kind of understand. So 4 is equal to 2 to the power of what number? We can do another one. So log of, let's say, 8, what is this equal to? Well, 2 to the power of 3 is equal to 8, so this is just 3. We can do some more. So the log of 16, well, this is 4, right? Because 2 times 2 times 2 times 2 is equal to 16. Then we have the log of 32. This is 5. The log of 64, 6, and we'll do one more. The log of 128, this is 7. Okay, now you can kind of start to see some pattern in here. We can see that as the log increases by 1, right? Plus 1. The n is actually multiplied by 2, right? So as the log of n plus is increased by 1, n is actually multiplied by 2, right? So the log of 4 is equal, the log of 4 is equal to 2, right? And the log of 8 is equal to 3. So this is the log of n, and this is just n, right? So you kind of understand that. So if you remember, these are our big O complexities, and I have a video on big O if you'd like to see that. I'll put it in the description down below. But you can kind of see how the relationship between n and log of n, right? So as n is really increasing linearly, and you can see the numbers increase from 4 to 8, 16, 32, 64, 128. Log is only increasing 2, 3, 4, 5, and 6, and 7, right? So you can see the steps that it takes to, for example, search a list of 128 elements. Doing it linearly is going to take 128 steps, rather than if you want to search it with log of n, right? This is only going to take 7 steps. Okay, so now let me show you an example of this log of n. Okay, so a really famous example is the binary search. So I'm just going to write it over here. So if you guys don't know, the binary search is just, let's say that we have a list. Okay, let's say we have just 5 different elements, and what we want to do is we want to find an element, right? And what we want to do is we want to find, let's say, I don't know, 5. Okay, so we want to find this element. Now, with binary search, we're just going to split the list in half, right? With 3, we're going to find the half, and we're going to see, is the element that we want to find, which is 5, greater than or less than or equal to 3? Well, we know that it's definitely greater than. So now we can just eliminate this whole side of the list, right? And now we just eliminated half. So every single step that we go, we're eliminating half. So now we only have 2 more, so we'll just split it in half. So let's say that we pick 4. And now we know that the only other element is 5. After we check is 4 greater than, equal to, or less than, we know it's greater than, our number is 5, right? And then we know that the only other number is 5. Okay, so we found it. And we found it in 2 steps, right? 1 and then 2. And we can also we can also like plug this into our equation and see if we're correct. So if we put log of 5 is equal to like 2 to the power of one number, well, 5 isn't a perfect power of 2, right? It's not. So we just go to the closest, and this is 4, right? 4, and then we just find out that it's 2, because 2 times to the power of 2 is 4. And also, similar, if we went to 8, then this would just be 3, right? So, yeah, so that's how we can actually find out that this is log of n. But, yeah, so that's pretty much it for logarithms. I hope you guys enjoyed this video. If you guys did, please make sure to hit the thumbs up and subscribe to the channel. And until next time, peace.